Okay, ስለዚህ cold gas system are the simplest type of rocket system which uses a simple inert gas to generate thrust. These are used for the last 1960s and how the design and construction of this cold gas. So there is propellant storage in this case. That means compressed or liquid gas propellants will be stored in this propellant storage. There is a nozzle construction here. Throat is there, divergent section and convergent section. The divergent section here and the convergent section here. There is a narrow section here. Okay, this is narrow section. Starting from here to here, we call that is nozzle. So the nozzle of cold gas thruster is generally a convergent divergent nozzle that provides the required thrust in the flight. Okay, so the nozzle shape is such that high pressure, low velocity gas that enters into the nozzle is expanded as it approaches to the throat. Look, this gas comes to the throat, and then once it reaches to throat, it starts to expand at the exit. Okay, so that throat is narrow section. You know that the flow is subsonic. Subsonic? No, it is transonic. Just Mach 1. በነገራችን ላይ እነዚህ ቃላቶቹን ስንጠቀም እንትን ማለት መቻል አለብን ብዙዎቻችሁ ላታውቁ ስለምትችሉ ሳብሶኒክ የሚል አለ ሳብሶኒክ የሚል ቃል አለ when the speed of some object is less than the speed of sound that means Mach is less than 1 Mach number ማለት በራሱ ምን ማለት ነው okay Mach number less than 1 Mach ማለት m is equals to speed of object v object let me say v of some object over v of sound ማለት ነው Mach number ስንል the ratio of speed of object to the speed of sound. So whenever the Mach number is less than 1, that indicates subsonic flight. Especially ለምሳሌ የምናየው እንደ ሄሊኮፕተር ያሉ ሳም አንዳንድ ደግሞ በዝቅተኛ ፍጥነት የሚሄዱ ኤርክራፍቶቹ በሳብሶኒክ ስፒድ ነው transonic ስንል transonic ስንል ደግሞ ምን ማለት ነው Mach is equals to 1 ማለት ነው Mach number is equals to 1 and
0.8
supersonic ስንል supersonic ስንል ደግሞ Mach greater than 1 ማለታችን ነው ከዛ በኋላ በጣም ሃይ ስፒዶች እንደ ሃይፐርሶኒክ የሚባሉ አሉ ስለዚህ these are some technical words እዛ ኤርክራፍት አካባቢ የተማራችሁ ሰዎች ግልጽ ስለሆነ ነው ሌሎቻችሁ ስላልተማራችሁ ነው ዝም ብዬ ማነሳውና እነዚህ ቴክኒካል ቃላቶቹን ወደፊት እንዳትቸገሩ ሶ እዚህ ጋር ናሮ ሴክሽን ኦር ትሮት በመንለው ትሮት ላይ Mach 1 ላይ በማክ 1 ነው ማለፍ ያለበት unless ደግሞ choking effect የሚባሉ ነገሮች አሉ ምንድነው choking እንዴት ነው hyper expanded nozzle and under expanded nozzle what is optimum nozzle የሚሉ ነገሮች next ላይ ወደፊት የምናየው ስለሆነ ትሮት ላይ Mach is equals to 1 ነው Mach 1 ማለት Mach is equals to 1 ማለት ምን ማለት ነው ትራንሶኒክ ነው። እዚህ ጋር ደግሞ ማክ ሌዛን 1 ነው። ማክ ሌዛን 1 this implies እዚህ ጋር low velocity high pressure low velocity gas ነው high temperature gas ነው and እንደዚህ region ላይ ደግሞ ከዚህ ከትሮት ቀጥሎ ያለው region ላይ ማክ greater than 1 that means supersonic. The flow of gas is in supersonic. That means high speed gas, high speed ejection gas coming out from here. So that is what. So cold thruster benefits from their simplicity. So that is the advantage of cold thruster, means simple design. It is cheapest one from all others. And its disadvantage is I will summarize all the advantage and the disadvantage of all types later. So let's go now. Here it is also many advantage and the disadvantage. You can read actually from here. I don't want to read one by one. One thing I can say is it lacks the lack of combustion in the nozzle of cold gas thruster allows it is usage in situations where regular liquid rockets engine would to be hot. And then now disadvantage, cold gas system cannot produce the high thrust that combustive rockets engine can achieve. So it is thrust production is less and less mass efficient than traditional engine rocket, and the maximum thrust of the cold gas thruster depends upon pressure in the storage tank. So it depends on the pressure in the storage tank, the maximum thrust which we can obtain from. So these are, and what type of propellants are used in the case of this cold thruster case? We use inert propellants, either solid, liquid, or gaseous propellant stored, which is stored in the chamber. But the propellant needs to exit the nozzle in gaseous form. This is a requirement. Storing liquid propellant may pose attitude control issue due to slashing of the fuel in its tank in high altitude. Again, when deciding the propellant to use, a high specific impulse and a high specific impulse per unit volume of propellant must be considered. So, and then the criteria መሆን አለበት. The second one is monopropellant system. The most usual monopropellant in rocket system is the hydrazine. Hydrazine is one of the monopropellant type, but we have many types of monopropellant like ethylene oxide, hydrogen peroxide, nitromethane. These are common monopropellants, but in most rockets for the last decades, people use hydrazine as one of the monopropellants. So monopropellant is chemical propulsion fuel which does not require separate oxidizer. It contains both of them together. Actually, it is not the kind of solid propellant, but it contains all the requirements there. So the rocket engine, which based on the monopropellant, requires only one fuel line. So it is not complicated like bipropellant. In bipropellant, we need two storage. So that two storage, there are feed systems, there are bulbs, and so on. That is very complex. Okay. And this diagram shows the monopropellant system. We have nozzle here. We have chamber here. Valves and openings are there. And the pressure vessel is here. The hydrazine N2H4. N2H4 is the chemical formula for hydrazine, and this is the structural IOPAC representation of hydrazine. Okay, so this is representation. So the maximum specific impulse እነዚህን ስፔሲፊክ ኢምፓልስ እንዳያሻሙ በኋላ ላይ የምንማራቸው ስለሆነ so the maximum specific impulse is 2.5 seconds and the thruster of 0.1 pound to be to several hundreds is possible with monopropellant ስለዚህ ይህን ማለታችን ነው ሞኖፕሮፔላንት ስንል ባይፕሮፔላንት ደግሞ ስንል ምንድን ነው look in the case of bipropellant we use two types of propellant oxygen and fuel maybe fuel is hydrogen okay that fuel can be another type of so we use two different tanks for oxygen tanks for fuel and there are pumps there are different pumps for the fuel and the oxidizer there are also some of them need some turbine for gas generator type it uses some turbine system and if we don't need turbine we have this type of okay this is what we call pressure feed rocket and this is pump feed rocket in the pump feed rocket we have some gas turbine generators turbines are required oxidizer fuel tank is obviously there so the system is highly complicated now it is not such easy as we see in the case of cold thruster and in the case of monopropellant it is not such easy so common liquid rockets are bipropellants we'll see liquid propellant rockets later that are called bipropellant systems it used to separate propellant liquid fuel and liquid oxidizer like LOX and H2O this contains in separate tank and are mixed only on injection into the combustion chamber and they may feed into the combustion chamber by pumps so this two figures shows us the bipropellant systems they produce high ISP means specific impulse okay it produces high specific impulse to 310s and the thrust capability is higher than the one which we have seen before and this system required actually some of the spacecrafts use nitrogen trioxide tetraoxide and monomethylene hydrazine this combination be one of the propellant or sometimes we can use liquid oxygen and hydrogen H2 this combination can be used in the bipropellant system the fourth one is solid motor rocket so in solid motor rocket the cast propellant will be placed in the combustion chamber with some ignition system okay so you may have some ignition system here aft ignition system or it can be there somewhere in appropriate place so this is a solid propellant which contains both oxidizer and fuel together in simple cast form and they are kind of plastic molding kind okay so that are manufactured for and these things are used for planetary orbit insertions and the geosynchronous APEC burns we use this type of propellants so these are the characteristics of different propellants cold gas solid motor monopropellant bipropellant so which type of chemicals we are using for example N2NH3 this ammonia okay ferrium helium so these are for the high pressure purpose ISP in the vacuum 50 to 75 seconds thrust range is 0.05 to 200 Newton thrust range in pound okay once we use ኢንተርናሽናል ዩኒት ይሄ ፓውንድ ምናምኖቹን ብዙ እኔ ተጠቃሚ አይደለሁም። ስለዚህ በኒውተን ያሉትን እዚህ ጋር ማየት ነው። and the bulk density, the average bulk density of the propellant is 0.28, 0.60, 0.96. So that is the density of in gram per centimeter cube. You can convert this to kilogram per meter cube. Okay, this is in the gram per centimeter cube. በምንድነው የምታባዙት? ይሄን ግራም ፐር ሴንቲሜትር ኪዩብ የነበረው ወደ ኪሎግራም ፐር ሜትር ኪዩብ ስትቀይሩ ግራም ማለት 10 the power of -3 ነው። ይሄ ደግሞ 10 the power of -2 ነው። በዛ አባስታችሁ ዴንሲቲውን ማወቅ ትችላላችሁ። ዴንሲቲ በነገራችን ላይ in propellant selection, density of propellant is one of an important parameter. Okay, so for that we have to know the density of the propellant. Another, for example, solid motor, we use organic polymers plus ammonium perchlorate plus some powdered aluminium. Now, the combination of these to be casted into solid. So it is chemical rocket. Monopropellant H2O2, N2H4, like hydrazine, hydrogen peroxide, hydrazine, again, bipropellant ሲሆን ደግሞ combination of the two, O2 and RP1, O2 and H2, N2O4 and MMH, again N2H4 and UDMH. እነዚህ ምንድን ናቸው? ቴክኒካል ወርዶቹ ፕሮፔላንት ታይፕ በምንማርበት ጊዜ ዋን ባይ ዋን የምናያቸው ስለሆነ ብዙ ምንድን ናቸው ብላችሁ እንዳትጨነቁ። ስለዚህ ፓራሜትሮቹ እነዚህ ናቸው ዲተርማይን ማድረግ የምንችላቸው። Okay, so when we come to particular chemical propulsion system, we have three types of chemical propulsion systems. One is solid propellant rocket, another is liquid propellant rocket, and another third one is hybrid one. Look, these are fully, the grain is casted into the casing, that there is a motor case here, there is a solid propellant grain, there is lining material. Lining material means the material which separates the outer casing with the inner propellant, hot propellant, so that some material which protect heat protection seals or liners, okay, which are placed in between here, and there is a igniter which ignites the propellant. ስለዚህ and then there is a combustion chamber. እዚህ ጋር ስንት ነገር እናገኛለን? 5 ነገር እናገኛለን በሶሊድ ፕሮፔላንት ሮኬት ላይ። ኦኬ፣ ወደዛ ስንሄድ አንድ በአንድ ስለምናያቸው ነው። አንደኛው the rocket casing itself. Please, እየሰማችሁኝ ነው?
አዎ።
ኦኬ፣ ስለዚህ እዚህ ጋር ሶሊድ ፕሮፔላንት ሮኬት እንዴት እንደ ኮንስትራክሽኑ እንዴት እንደሆነ እንድታውቁት ነው። What we are talking is the propulsion system. We are not talking about another pilot and another thing. The propulsion system alone contains here is the motor casing, then some sealant material or heat resistant material. There is igniter, solid propellant igniter, and then solid propellant motor itself or the propellant itself. Then the fifth one is the nozzle. So these are the basic constructional features of the solid propellant rocket. And when I come to liquid propellant rocket, we have fuel tank, we have oxidizer tank, sometimes there may be some pressurization tanks are there, and then there are some pumps or feeding systems, and then the combustion chamber is here. Again, throat is here, and this is generally throat, and some converging section, diverging sections are called nozzle. So nozzle, combustion chamber, pumps, tanks, tankers of fuel and oxidizer. So these are liquid propellant system. And hybrid propellant system may have oxidizer tank and solid grain of the propellant, solid propellant with liquid oxidizer, or sometimes it can be vice versa. Oxidizer may be in the solid form, or fuel may be in the liquid form. So it depends on like that. Okay. This is a general construction of solid motor, solid rocket motor. Look, the technical words: motor is for the solid rocket, engine is for liquid rockets. So whenever we say engine, it is liquid rocket. So now we are saying motor, solid rocket motor, or in short, SRM. So this solid propellant rocket motor, ingredients to burn are already stored within the combustion chamber or in the casing. Casing means the one which shelters all the inner parts. Okay, it is within the casing. And the solid propellant is called grain. The propellant itself here, the solid propellant, what you are looking here, is the grain which is casted or which is manufactured in different method. Okay, and it contains all the chemical elements for the complete burning. That means fuel and oxidizer together, casted together on it, on the grain. Once it ignites, it is designed to burn smoothly at a predetermined rate on all it is exposed internal grain surface. Look, this solid propellant have one disadvantage. One very big disadvantage is once it is ignited, there is no way to terminate the heat or to stop the ignition. Once it ignites, means it is already done. You cannot get that rocket back. Okay, that is one of the big drawback of solid propellant rocket. So whenever the exposed part, there are two sections in solid propellant. One is inhibited part. We shield the surface which is not expected for burning will be shielded with heat. Fire resistance material, and the part which is exposed for burning, there are different geometric shapes are there, but simply considering cylindrical inner shape like this is the surface to be ignited. Okay, when the igniter starts, this surface immediately caught by fire and start produce hot gas inside this chamber. So this is the thing. Initial burning is take place at internal surface of the cylinder perforations. There are perforations, star-shaped or simply small cylindrical, or various geometric aspects are there. We can see somewhere it is here. Let me show you. Look, this is the way how it is burning. I want to show you some. Yeah, this is a star shape of propellant. Various designs are there. Okay, these are perforations. Okay, this is simple cylindrical shape like this. So each of them gives us different thrust and the time curve. This thrust time curve is one of important parameters in the selection of the shape of our solid propellant. So then another is igniter. This is also another chemical which is very fire sensitive chemical, which produces high heat at the very instant moment when we provide some electrical energy or some other means to ignite it. So once the igniter starts ignition, the inner part of the propellant starts to caught by fire and starts to produce hot gas that will be accelerated through the convergent divergent nozzle here. This is the nozzle attachments. Okay, this is as a whole called nozzle design. Yeah. So when we are considering nozzle design, we must consider the erosive burning that comes out from the combustion chamber. So high propellant gas are coming through the nozzle. So the material that must withstand all the temperature, all the stress, all the pressures should be considered for the design of the nozzle itself. And sometimes we use some graphite materials to resist the erosion of the this part. Okay, then it is sealed with some insulation material or heat resistant material, because the heat from combustion chamber or from the propellant will not propagate to the outward to the casing. If it goes, the casing will be destroyed and the whole rocket will fail. So that we have to shield it with some fire resistive material. So that is known as insulation. And the outermost cover is the metal structure that is called the casing. Okay, so this is a general construction. So I used some of them, these pictures from my MTech project. So that will give you a brief idea on that. Okay, so this is a general construction of solid propellant rockets. I already discussed everything for you. Igniter is there, motor case is there, internal insulation is there, thrust vector controller, the burning control mechanisms, propellant grains is there, nozzle throat or nozzle itself is there. So this is a general solid rocket motor construction. So now one of the part is solid rocket motor casing. Look, RMC is for the casing, the outer part, the one which encloses all the structure inside. Okay, so the rocket motor case generally consists of steel or aluminum tube with the head end dome containing an igniter, and an aft end dome contains the nozzle. So look, here in the aft end we have igniter, and at the this part we have nozzle. So two attachments are there on the casing. More preferably, this shows you a casing ነው ያያችሁ ነው። ይሄ casing በዚህ በኩል የኢግናይተር አታችመንቶቹን ይዟል። በዚህኛው በኩል ደግሞ የኖዝል አታችመንቶቹን ይዟል። This is nozzle attachment. So this is geometric construction. So the motor case is ordinarily have insulation, okay, on their interior surface. So especially this not covered by the propellant. So exposed on the propellant to heat to transfer እንዳይሆን የሚከላከል part ማለት ነው። So rocket motor casings are designed with high strength steel. በነገራችን ላይ በጣም high strength steel ወይም ደግሞ sometimes ውድ የሆኑ ሌሎች steel አለ. It is called as maraging steel. Maraging steel የሚባለው አለ. It is not easily available. Very less quantity ኢትዮጵያ ውስጥ በአምቦ ውስጥ ይገኛል አውቃለሁ። በውድ ዋጋ የተገዛ ነው እና እንደነዛ አይነቶች ናቸው አንዳንድ ጊዜ የምንጠቀማቸው። And another second method of using material for the casing is filament winding. This is called composite manufacturing system. We use filament winding of the composite or high strength steel material be suitable for the casing. So this is the motor case. Okay. Another is solid propellant. So this is the propellant. This is the solid propellant. When it is caught by fire using igniter, how the hot gas are coming out into the nozzle. This figure shows. Okay, it illustrates like that. So እዚህ ያለው solid propellant የምንለው ምንድን ነው? So solid propellants are solid cast materials containing both fuel and oxidizer. They are cast materials which are bonded in suspension that can produce thrust through chemical reaction. The fuel can be handled at room temperature until an ignition source is applied. That means through ignition. When the propellants are ignited, they release both the fuel and oxidizer constituents, which burn in to generate thrust. That is our aim. So, in iመስላል solid propellant rocket. You can see the remaining thing. The material for solid propellant rockets means solid propellants are like the ingredients ammonium perchlorate in the granular oxide with granular oxidizer. This is ammonium perchlorate oxidizer, no? Powder aluminium demo fuel, no? So powder aluminium as a fuel, ammonium perchlorate as oxidizer. And also we use some hydroxyl terminated polybutadiene, HTPB. This is called hydroxyl terminated polybutadiene. That is also used as fuel that is leaked during mixing and the plasticized to the rubbery binder during curing. So HTPB as a curing agent. At the same time, liquid fuel now. ስለዚህ የነዚህ ኮምቢኔሽን ነው አንድ solid propellant የምንለው። ይሄ as example ነው. This is not the only one. There are also some higher performance solid fuels, like for example energetic oxidizers like acrylo. እነዚህ ኬሚካል ስሞቹ ከባድ ናቸው። anyways cyclotetramethylene tetranitramine, for example HMX, ወይም በቀላሉ እናንተ ይሄን ለመጥራት ከፈለጋችሁ His Majesty Explosive በሚለው መጥራት እንችላለን። HMX means His Majesty Explosive. They are called cyclotetramethylene tetranitramine. So this is one of the oxidizer. And by energetic plasticizer or binder such as nitrocellulose nitroglycerin, that is double base propellant. Nitrocellulose nitroglycerin is double base propellant, no? ስለዚህ this is one of the high performance propellants. And also we have another types like tetranitrotoluene ወይም TNT በሚለው ቃል የምናውቀው ማለት ነው። TNT ሲባል ብዙ ጊዜ እነዚህ ፈንጆች ወይም የተለያዩ ለእንትን ምንድነው ሮክ ዲሞሊሽ ለማድረግ የምንጠቀማቸው እነዚህ ከፍተኛ ኤክስፕሎዥን የሚፈጥሩ እንደነ TNT 246 ትራይናይትሮቶሉene ይሄ የአዮፓክ ስትራክቸራል ሪፕሬዘንቴሽናቸው ነው። Like RDX means research and development explosive ማለት ነው. It is chemical formulation is like this. You can go through it. And HMX ራሱ በኬሚካል ፎርሙሌሽን ስናስቀምጥ እንደዚህ ነው። Okay, so እነዚህዎች ናቸው ለእንትን የምንጠቀማቸው ለፕሮፔላንት ለሶሊድ ፕሮፔላንት ካስቲንግ የምንጠቀማቸው ማለት ነው። So these are some particular shape of solid propellant, star shape, some cylindrical shape, some perforated shapes. የነዚህ burning rate በኋላ ካልኩሌት እናደርጋለን. How they are burning? Is it corrosive burning? Is it progressive burning or what it is? That we will see in the next. In some times after. Okay, so ይሄን ይመስላል solid propellant ስንል requirements of solid propellant ሶሊድ ፕሮፔላንት ማሟላት ያለባቸው ምንድነው? እኛ የኛ ካጠቃቀማችን so the propellant charge must meet variety of conflicting requirements. The requirements by itself are conflicting. Okay, so among them, from the performance standpoint, performance is one of the things which we need. They should burn inward to the burning surface. ምንድነው ባርን በሚያደርግበት ጊዜ ኢንዋርድ ባርን መሆን አለበት። ይሄ ዲቶኔቲቭ ባርኒንግ ወይ መፍጠር የለበትም። progressive burning ማሳየት አለበት። as the propellant burning in progressive manner, that the amount of hot gas coming out will be increasing from time to time. So for that, the bulk temperature at rate in the charge should be 0.2 centimeter per second to 20 centimeter per. This is burn rate. Burn rate R dot የሚባል ነው። ይሄ ወደፊት የምንማረው ስለሆነ propellants should be as dense as possible. Density is one of the important parameters for the selection of propellant. So the higher the density, the higher energetic the propellant is. So that is what. And the molecular mass should be low. Low molecular mass is required. High density is required. High temperature should be required from the
ደቂቃው ልዘጋብህ ነው መሰለኝ።
ሄሎ
ደቂቃው ልዘጋብህ ነው መሰለኝ።
ምን አልከኝ?
አይ ደቂቃው ልዘጋብህ ነው መሰለኝ።
ኦኬ እሺ። በሶሊድ ፕሮፔላንት እንትን እንላለን። ቀሪውን ኔክስት ስለምንቀጥል ኔክስት እዚህ ጋር ምንድነው ከዘጋ እንትን እንላለን። This nozzle is the second part. Means we started with casing, then propellant, and then the third one is nozzle. So nozzle have shape like this.